Well, hello everyone, and welcome to the August 2021 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is kind of an informal group. We've been around for many years, since I believe 1997. Attendance is free. There is no formal membership list. Our normal meeting date is the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to be able to organize a meeting during the month of December. When we meet in person, you're able to join us for food and social at 6 p.m. and the meeting will start at 6:30. When we do meet in person, our normal meeting location, or at least it was in the past before the pandemic, in the Object Computing Incorporated training room. We're at 12,140 Woodcrest Executive Drive, Suite 310 in St. Louis, Missouri. I'd like to introduce the rest of our steering committee here. So from left to right, we've got Ted Doyle, Todd Zimmerman, Bruce Alspaw, that's me in the center, Weiqi Gao, and Kathy Zwang. You can reach all of us on the steering committee if you send an email to that address that's on the bottom of your screen right there. That's javasigsc@ociweb.com. The St. Louis Java Users Group would not be possible without the support of our JUG sponsors. So I've got some of their logos up here right now. I'll just start up here in the corner. Object Computing Incorporated, they are our founding sponsor. They have been with us continuously, supporting us since, 1997, before I was ever even close to even being on the steering committee, before I'd even heard of the group. JFrog has been very supportive here, especially getting us through this pandemic. They have covered the fees for the Zoom account that we are using right now to bring this meeting to you. They also cover the subscription fees for the meetup group. Now, it's free for you to RSVP and attend a meeting, but it does cost the group some money to be able to have a website and a page on the meetup.com website. So thank you to JFrog for sponsoring us. Signature Consultants and Adaptive Solutions Group are headhunters. So if you are looking for a position, give them a call. You can find them on the web and let them know that you found out about them through the St. Louis Java Users Group. They have been very good at sponsoring the food about every third meeting when we meet in person, but we haven't figured out a way how to send pizza over the internet. So unfortunately, we haven't been able to take advantage of that. At the end of this meeting, for those who are present in the Zoom meeting, we will be raffling 2 JetBrains licenses. So of any JetBrains product of your choice. Now, if you're just watching the recording afterwards, I'm sorry, you're too late. You must be in the meeting to be able to win the raffle prize. Elastic, they're the folks who sponsor Elasticsearch, have some gift cards, and we're holding on to those. So as soon as we're able to meet in person, we'll be able to raffle those. So we appreciate the sponsorship from Elastic. Intertech is a training company that has lots of training videos on a whole wide variety of topics, and they sponsor some coffee cups, mouse pads, but also the famous screaming flying monkeys. Now, what in the world are those? Those are like little dolls, and if you throw them up against the wall, they scream. They're really cute, and they're a lot of fun. At the end of the meeting, we will also be raffling 2 Manning ebooks of your choice, again, for people who are actually in the Zoom meeting. Pearson also is a sponsor of Computer Books. They've got physical books that they will send to us on occasion. So thank you to all of you for your support of the JUG. As far as announcements go, we've been working with Jay at No Fluff Just Stuff, who puts on those conferences. That is coming up. That will be October 22nd to the 23rd, starting at 7:30 a.m., I believe, on the 22nd. And that No Fluff Just Stuff, also known as the Gateway Software Symposium Conference, will be then, the in-person, I believe, is supposed to be at the St. Louis Marriott West. There is an online and an in-person option, so you can attend either way, whichever way you feel most comfortable. But if you want the details on that, it's nofluffjuststuff.com/St. Louis. And if you're watching the meeting, here's an incentive to think about coming to next month's meeting. Normally, as we get closer to the meeting, we will raffle a ticket to No Fluff Just Stuff. Now, I'll have to get back in touch with Jay and make sure we can still do it again. But that ticket could be worth quite a bit to be able to attend that conference if we're able to do it again as we have in the past. He's been very nice about that. So as far as upcoming presentations go, on September 9th, we have Getting the Most from LTS Java. And that's by Simon Ritter of Azul Systems. Now, Azul produces Zing and Zulu, those JVMs. And if everything holds true, we should be either already have released or pretty close to Java 17. And if I understand correctly, Java 17 is going to be a long-term support release. So that one could be around here for a while. So we thought that it would be good to have him come in and tell us about the new features that are coming in this next long-term support release. On October 14th, we have scheduled Jakarta EE, Present and Future by Reza Rahman of Microsoft. I believe he is a well-known speaker on the speaking circuit, and he makes sure that basically Java is a first-class citizen on the Microsoft Azure platform to make sure that, you know, it really is first class. It's not just that other .NET language. Anyway. So as far as upcoming presentations go, the way to keep track of that is to just visit the meetup site. That's meetup.com/gatewayjug for any updates to the presentation schedule and location. Now, if you are interested in giving a presentation or being a sponsor of the JUG, just send us an email to that email list that I said earlier, and I've got it there again. That's javasigsc@ociweb.com. Again, if you want to get a hold of us or give a presentation, we're always looking for presentations here. So with that, we are on the Quarkus World JUG Tour. And so I believe the title is All Rock and Roll and Break Drum Solos by Christopher Bolland of Red Hat. So I'm going to see if I can find the correct button where I can stop sharing, and that will allow Chris then to share his screen. Let's see if you can give that a shot. And then I'm going to mute my microphone so you can take it away.
Thanks, Bruce. Let's see if this does in fact work. So it says host disabled participant screen sharing.
Now try, I changed the setting.
Hey, there we go. All right, I'm gonna go with desktop 2. Let me know if this is working for you guys. You can see?
Not seeing anything yet.
Not yet. How about now?
Now I see.
Outstanding. All
It's
right.
looking good now. Take it away.
We'll move into presentation mode and just one more confirmation. Still good?
Looks good to me.
All right, good deal. Well, thanks, Bruce. I appreciate the opportunity to be here. I've had a lot of fun working with Quarkus, and I'm excited to share that with you guys. The rock and roll theme might be a little bit overblown as far as my own presentation style is concerned, since it's just me and I don't really have a band. But we'll see how exciting we can get. I guess it's all going to be drum solos since there's no other people in this band right now. So a little bit about me before we jump into this. I'm Chris Bolland. I'm based in St. Louis, Missouri. I'm a cloud platform solution architect for Red Hat. And what that means really is I'm a solution architect around our OpenShift Kubernetes products, as well as our middleware products, which also include, did I lose you guys?
Yeah, you're looking good and sounding good.
Okay, I just had a major power blip here. Sorry about that. I don't know if you saw the blink. My room went dark for a second. So all things Kubernetes and middleware is typically my day job. I've been at Red Hat for about 3 years. Prior to that, I did a long stint at Panera Bread in a heavy application development role. And if you've actually used Panera's loyalty program, the My Panera program, then you have used my code, and you have shared with me your personal data, although I left it at Panera when I left. But anyway, that's a little bit about me. We're here, though, to talk about Quarkus. What is Quarkus? And really what we've seen over the last number of years is a change in application architecture. We used to write all these big monoliths and we deployed them into large application servers. But now we've evolved from that into doing things in a cloud native way, or perhaps decomposing those monoliths into microservices, or maybe even decomposing those microservices further into serverless applications that aren't even running all the time, but simply respond to requests as they come in. And those things can lead to more sophisticated event-driven architecture. So we've seen a lot of change in that application growth. And when we ask ourselves, well, what is Quarkus? The main idea behind Quarkus is creating a Kubernetes native Java. And so what that means is a Java that is particularly well suited for running in a Kubernetes cloud native environment. It is particularly well suited for microservices, serverless and event-driven architectures. And it's particularly well suited for some of the ancillary components around a Kubernetes, such as doing Istio, or Knative is actually a way of doing serverless architectures. So really, what is Quarkus? It's simply an open source stack to write Java applications. It's a way to take Java apps and Java developers, more importantly, and give them a real on-ramp into doing Kubernetes native development. Why? Well, if we look at this historical enterprise stack, this is what we were writing years and years ago. We had our monoliths. We had a variety of applications. Each did a whole bunch of stuff. They were deployed on app servers, whether it was WebLogic or WebSphere, JBoss. They typically ran for months in that application server. They took up tons and tons of memory. And since they ran for so long, if it took them tens of seconds to get going, to start up, that really wasn't a big deal, because over the lifetime of the application, you know, tens of seconds isn't that big compared to the months and months that it's running. When we look at the modern enterprise stack, really not that much has actually changed. We may have decomposed that monolith into a series of microservices. So maybe we've moved into a single application, and we're still using those dynamic frameworks. We're still typically deploying this onto application servers. We're still using a bunch of RAM, and maybe we've cut down the start times significantly from tens of seconds, but it still takes a lot longer to start a Java application, even in a modern stack, even with microservices, than it does say a Node.js or a Golang application. And so when you talk about Java developers and Java code having a footprint in this new cloud paradigm, there's a need for that new Java stack, and that is Quarkus. The name's a little bit weird, so I wanted to take a minute and just talk about where that name came from. And it's really a combination of quark, which is one of our elementary particles from physics. The idea using quark is that it is super small and super fast, and then us being people, the hardest thing in computer science. And so that's where the name came from, a mashup of quark and then us. Another way to think about it, the official tagline actually is supersonic, so super fast, subatomic, super small, and yet still, as we all know and love, Java. So why? What are the differentiators with Quarkus compared to, say, that modern Java development stack? First of all, it's container first. Quarkus is designed to run inside a container first and foremost. Does that mean you have to do that? Absolutely not. But it means that it is designed to take advantage of running in a Kubernetes system inside a container-based platform. You can run it with a JVM using the hotspot, or you can run it compiled actually into native binary. So native bytecode, I'm sorry, not even bytecode, native executables that do not require a JVM. So what that does is gives you much faster boot times, much lower memory requirements, and it makes it actually possible to do serverless really. I mean, you could write a serverless app in Java, but it's not, no one's going to want to use it. You can really do serverless well with Quarkus. Another thing is developer joy. So, and we're going to see a lot of these things as we go through some live coding later on, but the live coding part. So our friends that do Node.js, for example, or PHP, they're able to write some code, save the file, and see that change instantaneously. Java developers, we typically don't have that luxury. We're stuck in that save, compile, deploy, test phase. And depending upon the number of changes you make, that can take a while. So this live coding can really make it a lot more fun, make the developer a lot more productive. Similar with unified configuration, what that really means is Quarkus has a single configuration file for everything. So no more, 3 or 4 or 5 different XML files to chase down. Quarkus also unifies the imperative and reactive styles of programming. Imperative is what we grew up with. It's just line by line sequentially going through things. Reactive programming is much more on the lines of what Node.js is doing. Streaming-based applications are typically written in a reactive style, where you've got asynchronous I/O. Quarkus does that with the Vertex built-in event bus. And then finally, in terms of differentiators, the best of breed of libraries and standards. So there are lots and lots of extensions to Quarkus. And when I say extensions to Quarkus, what that really means is a dependency in your pom.xml. But Quarkus makes it very easy to pull in and manage those dependencies. And so as a Java developer, when you look at the Quarkus ecosystem, you're probably like, well, I know how to use that, and I know how to use that, and I know how to use that. And since Quarkus is really, it is just Java, it's a Java framework, I know how to use that too. And so my goal today is to introduce you to Quarkus and then give you a springboard for going out and trying it on your own. So that first benefit, I want to talk a little bit about that because this is huge, being container first. So reduced memory footprint. If we look in that gray set of boxes, your traditional cloud native stack, and we really can't point too many fingers in printed material when we say traditional cloud native stack, but really what that means is a Spring Boot application. So your typical Spring Boot, and I'm not knocking Spring Boot, all of the My Panera stuff that I wrote back in the day was all Spring Boot stuff. So I've written a ton of Spring Boot code, and it was great stuff for the time I was using it. But it does use a significant amount of memory, particularly if you're deploying it in the cloud, which we were not. We were running it on WebLogic. Quarkus, even using the JVM, will shrink that memory requirement down, basically almost in half, and compiling it to a native executable, getting rid of the JVM gets it down to even much smaller memory. Similarly with startup times, that traditional cloud native app, it's going to take 2, 3, 4 seconds to start up. Quarkus in the JVM might take a second or less. Quarkus and native compilation, you're talking about hundredths of a second, 0.0, some very small number to actually go from startup to time of first response. And then a smaller disk footprint. These benefits are huge from an economics perspective when you look at cloud deployments. When you look at a cloud deployment, you're typically not scaling for CPU usage. What you typically have to spend more on is memory consumption and your footprint on disk. So if you've got an application that you can shrink its memory requirements down, you can either save money by not deploying as many or deploy more applications for the same amount of money. This is huge in that cloud space though, because when you think about how the cloud scales, it's all about horizontal scalability, which means that as your need to respond faster, add more processing power to it, you're going to introduce new instances of that application. 1, 2, 3, 4. If those instances all have huge memory requirements, then you're very quickly going to run up that cloud bill. The more you can constrain your memory, the better off your cloud economics are. And this is really why. When you look at that hotspot, it takes a ton of memory to run that hotspot heap compared to something like Node.js or a Golang application. And this is really the trade-off that enterprises are making when they look at developing new applications in the cloud. They can do traditional Java applications where they've got people to staff it, but it costs them a ton more to actually run those applications in the cloud versus doing something with, say, Node.js or a Golang app. Basically the same information here, much smaller memory utilization. We'll actually see this. We're going to, I won't run a Spring Boot app, but we will take the same Quarkus app and compile it into a native binary as well, and then compare the amount of memory it takes to run that application. We'll also look at startup times as well. The idea being that even when you add the CRUD-based applications, so not just a serverless app, for example, but if you add in your database access, everything gets a little bigger, but Quarkus is still significantly smaller than your cloud native apps. Also much faster start times, as we were talking about. And again, even still with those CRUD-based database apps. So when you look at Quarkus, and we expand out from that previous slide, on the far left, that's your traditional stack, whether it's JBoss, WAS application server, or Spring Boot. You've got, so many that you can run. If you write your app for Quarkus on the JVM, meaning it's a traditional Java app, there's still a JVM when it gets deployed, then you are going to achieve the same efficiencies in terms of memory utilization and startup times as you're going to get with a Node.js application. If you compile that Quarkus application all the way down to a native app, and it's not necessarily that every app is suitable for native, and we'll talk a little bit about which ones might be, which ones might not be later on. But if your application is suitable for being compiled into a native executable, you can actually get down, reduce those requirements, memory requirements, and increase or decrease those startup times so that you actually get on parity with Golang applications. As a note, and this is an aside from the cloud perspective, but as a note, what turns out is very interesting, I think, is the requirements in terms of running in the cloud. So we're talking about really constrained memory requirements because of the economics, and the need to have super fast start times, because when you go to Amazon, when you go to Google or Apple, those guys have set a really high bar, and consumers now expect all of us to be able to meet that. When you look at those things, what's interesting is that those requirements for the cloud now are the same requirements you'll find on the edge. So when you think about that, very small application space, you need apps that can run in very constrained areas, and they need to be able to start very quickly, particularly if they're doing event-based types of paradigms down on the edge. That makes Quarkus, particularly when compiled with into a native executable, really well suited for edge deployments. For me, as a former Java developer and somebody who actually cares about all of my Java developers still working in the space, is that typically Java developers have not been deploying apps into the edge. That's not really an area that we had access to, mostly because Java wasn't suited to be deployed into the edge. Not only was the app too big, you also had to deploy a JVM to go along with it. And then that led to operational issues and challenges. We had to patch the JVM and all of that stuff. With Quarkus, compiling down to native, and this is a benefit for the programmer. Now you've got another place where you can deploy your code. You're more valuable. Also a benefit for the enterprise. When you think about who knows your enterprise code the best, it's going to be those Java developers. They've been building your business for sometimes decades. They know your code. If you can expand platforms where they can deliver it, not just to the cloud, but out to the edge, think about how powerful that is from an enterprise perspective versus to have to bring in brand new hires who don't know the business, who don't understand what's going on. If you can take the folks that have built your business and give them tools so that they can take what they know, Java programming, and still make it run on the edge, that is a fantastic win for the business. So the second one, developer joy. So this is awesome. You're typing along, and we're going to do this in just a few minutes. You're writing code, you save the code, you immediately see the change. You do not have to recompile Quarkus when it's running in dev mode to see changes as you go. And live coding simply does away with that. And it makes it, just easy and fast to write code. So I mentioned about the imperative and the reactive. So on the left, we've got our imperative style. We've just got a method. We return whatever the method says. On the right side, we're doing stream-based processing. We've got a publisher, and we're just returning that stream as events are written to it. Quarkus can do both of those. You don't have to say, oh, I'm an imperative programmer, or I'm a reactive programmer, or even this application is only imperative or reactive. You can mix and match that technology to best suit your use case. And there's been such a growth in the need for reactive-based programming, particularly as event-driven architectures and things like Kafka and stream-based programming has really, really taken off. So, and I'm just going to read the top quote because it really is something that I want you guys to take away from this. When you adopt Quarkus, you'll be productive from day one since you don't need to learn new technologies. This is Java, and it's using some of the Java frameworks that you're probably already familiar with. Vertex, if you're already doing reactive-based things. Hibernate is one of the most popular ORMs. REST Easy, if you're building REST applications. Camel, if you're doing enterprise integration patterns. Kafka, as I had mentioned. All of these things are already and able to be used with Quarkus, and you don't have to do anything new or different to take advantage of them. So a lot of benefits. Well, let's step back a second and talk a little bit about, well, how does Quarkus work compared to other things? What is the magic that's going on? So let's first start with, well, in our old Java lives, what actually was going on? So we had our build time. We were writing code, then we would package it using Maven or Gradle or whatever. I'm going to use Maven today. Then in runtime, the application actually had to do a bunch of work before it could start serving requests to it. So you had to read the config file. You had to, because most of our modern Java frameworks are very dynamic, you had to do class path scanning, find all the annotated classes, load the classes, figure out which features to enable, which to disable, build out that model of what the application looks like, and then go ahead and start the thread pool. And then finally, you're ready to start serving applications. So that's why when you look at our traditional Java apps, the build time can be fairly short, but that runtime, you've still got 3, 4, 5 seconds because there's a ton of work being done then at runtime. What Quarkus does is shift all of that runtime stuff, most of it anyway, into the build time, so that configuration files. Quarkus doesn't actually use dynamic loading of libraries. It builds out its model ahead of time, and it gets ready to run so that when you start the application, the only thing that needs to happen is bringing up the thread pool and start receiving requests. And so the build time for a Quarkus application may be a little bit longer. That runtime is going to be much shorter, particularly when you look at native compiled applications. Now, when we do the live coding is a little bit different. The live coding isn't designed to be a production application. So we're not really doing build time. When we first start in dev mode, it will take a little bit longer than it will if we were running, if we had done a Maven package, for example, and then done a java-jar on our app. So we'll compare those things so that you can see what's actually going on in those time differences. Oops, went too far. See if I can go back. There we go. So I spoke a little bit about, we've got the ability to deploy to a JDK hotspot and running in a traditional JVM, or compiling to that native binary. And it might not be always appropriate to choose the native image. It seems really cool, but maybe not all the time. And so the question is, when do you want to choose the OpenJDK? When do you want to choose the traditional way of deploying a Java application? So really, when it comes down to raw CPU performance, if you care about the garbage collection going on, you can actually add more heap size. And then this is the biggest one that I've found as enterprises are delivering Quarkus applications. Right now, there aren't really that many monitoring tools for the native images. And that's because they're basically static when they are built. You cannot inject those monitoring tools into the JVM at runtime. If you need to do that, because there's no JVM, if you need to do that, then that's really the biggest reason I've seen that people are moving there or staying with the traditional JVM, because they've got the known monitoring tools. The other thing that gives you is our traditional mantra of Java: compile runs, run anywhere, because of the JVM and the magic of the JVM. That is still true for Quarkus. When you compile to a native image, that binary is only going to run on the architecture that you've compiled it to. I mean, it makes sense, but that is a limitation of sorts. And when we a little bit later on, when we do that, I'll do it first for a native image on my Mac, and then we'll actually build a native Linux executable. There's not that many cloud applications that are running Mac executable, so it wouldn't be all that helpful to have that. But it will compile and run natively on my Mac. I mean, it is kind of fun to do both of those things and take a look at the differences. As I mentioned, build tools of choice. I'm going to use Maven. You can use Gradle as well. And then you saw the scaffolding there. That's what we're going to do today. The Quarkus provides a website where you can go. I think it says start coding is the button, and you can actually fill out some stuff a little bit like Spring Boot. Pick the extensions or the dependencies that you want in your application, and either have it generate and either download that as a zip file, which you can open up, or it will it can actually push that into a Git repository for you from the web page. But we're going to use the Maven scaffolding just to keep it a little bit easier. The tools are exactly the same that you'd expect. We talked about Maven and Gradle, same with the IDEs. I'm going to use VS Code, but you can use Eclipse or IntelliJ. You can use Che. Che is based on the Eclipse Che project, which is doing an in-browser IDE. Or if you're old school, you're more than welcome to use Emacs or VI or whatever floats your boat. It's like I said, this is literally just Java. So the tools you're already using, you can continue to use with Quarkus. And as I'd mentioned, that extensible ecosystem. So whether you want to do connecting to Mongo databases or Postgres databases, which we may have time to get to today, all of these tools, everything that you would expect to use with a modern Java application, you'll have available to you with Quarkus in that ecosystem extension. And then finally, and this is a big one for me, is making serverless available for Java applications. I mentioned a little bit about how I was super excited that Java developers now finally could reach into the edge and write Java code that was really well suited for edge deployments. The same thing is true for serverless apps as well. Right now, not many people are writing and deploying applications, serverless applications in Java. And the main reason for that is start time. The whole idea with the serverless application is that it is not running until that request comes in. And then the application starts and answers the request. The reason that's a big deal is economics. If your application isn't running in your cloud provider, they're not charging you for it. So if you have a lumpy business cycle, for example, if you've got nothing going on overnight, why are you being charged for applications running overnight? Or perhaps you'd like to be able to scale closer to your curve so that instead of having a whole bunch of applications running, doing nothing, and then scaling up and scaling down, you could scale to 0 and then scale up to meet that demand and scale down. And it makes sure the economics of running the application match the requests into the usage of that application. But that doesn't actually work with Java right now, as Java is traditionally known, because of those start times. So most serverless languages or most serverless apps are being either written in one of the scripting languages like Node or Python, or Go probably should be a higher up on this list, but it's a little bit of a steeper learning curve. And I would expect Go to rise on the list and probably supersede Python. Node is a pretty friendly language to use. It's just JavaScript, so not that hard to get going with. But Go does have a significant learning curve. The idea behind Quarkus is to take that Java number and push that to the top. There are tens of thousands of Java developers and enterprises, probably hundreds of thousands across the world, and to open that paradigm up for Java developers. So the people that know your business can actually not be locked out of the newest way of delivering functionality, the newest way of creating value in the cloud. So super exciting stuff there for our Java developers as they're moving into or trying to move into deploying apps into the cloud. So this is what Quarkus looks like. We've seen a version of this slide, 2 versions of this slide actually early on. You're typically deploying a single app. It might be a microservices app. It could be a serverless application. Your application lifecycle, no longer is it running for weeks or months. Really, it's milliseconds if you're doing a serverless app. Microservices, they might run for days if they're running in the cloud. And that's because in a Kubernetes type of environment, it is designed to scale horizontally in a very elastic fashion. So you may have 2 versions of the app, 3 versions of the app, 10 versions of the app, 1 version of the app. And so it may be around for a while, it may not. And then the idea, as we've talked about, is to cut down on that memory consumption and to cut down on those start times. And as it notes here, and I've said a couple times, that JVM, completely optional. So that's usually one of the things when you talk to operations people, they get really excited about not having to worry about vulnerabilities in the JVM. If you compile down to native, you'll still have bugs, you'll still have vulnerabilities. It's not a magic bullet that way. But what you've done is remove one more component from those problems. So now you don't have to worry about patching your app server. Now you don't have to worry about patching a Tomcat to run that JVM. It's just one less thing to manage. Generally makes the security people happy too, for exactly that same reason. I know there's been a ton of places where I've been where they said, well, we'd like to be able to patch the whatever, but we can't take the app down because it's running unpatched and it's unsecure. So I'm going to jump into a little bit of live coding with you guys. Before I do that, if you want to try out Quarkus, Red Hat has a developer sandbox, which will give you 30 days of OpenShift access for free to deploy Kubernetes projects and Quarkus projects into. So you can go to developers.redhat.com, and then there's a link to the developer sandbox. It is completely free. I think you do have to have a login with Red Hat, which is also free. But yeah, you've got 30 days, and you can go forth and really, build your own applications up to 3 different projects, including CI/CD and pipelines and GitOps and everything else you would want to do. So just a bit of a commercial there on the Red Hat side. Quarkus 2.0 just recently released. That brought a bunch of new features, including the dev console, which is when you're running in dev mode, it's a way of graphically looking at in a web page all of your configuration options, your extensions. You can actually modify them using the web page versus having to go in and poke it on the fly. It also gave us the ability to do continuous testing. And that's actually a really great concept. If we don't get to it tonight, we can always come back and talk more about it, or you guys can hit me up individually. The idea behind continuous testing is that you've got dependencies. Let's say you've got a database dependency on your Quarkus application. You're writing that app. Sometimes you can't connect to that dev database out in your infrastructure, or you can't make changes to it because of, you need to connect with the DBAs and see what's going on. You need to have change requests, all things like that, even if it's just dev. Running with the continuous testing, what Quarkus will actually do, it will recognize, oh, you've got a Postgres database dependency started here. I'm going to go ahead and start a Postgres instance in a Docker container for you and wire it up, so that as a developer, it removes that bit of work that you have to do. You don't have to go out and find your Docker container, or you don't have to put in change requests or find a DBA to get that shared instance of the dev database fixed up for the code you want to run. You can be productive right out of the gate using a real using a real Postgres database running with your application. And when you shut the app down, since it's running in a Docker container, it goes away as well. And of course, then what you would probably do is have some setup statements, some SQL that you would run when it starts, pre-populated with whatever data needs to be there, so that you can continue your testing. But the idea is to make developers as productive as possible, as quickly as possible, and remove barriers and roadblocks to all of that. So there's my rock and roll hands. I will provide the slides to Bruce, and he can share that with the group. Quarkus.io is the website. There is a Zulu chat or Zulip chat room if you'd like to join that. You can follow Quarkus on Twitter. There is a free book. This O'Reilly book is sponsored by Red Hat. You can download that for free at the bit.ly link there. And you're certainly more than welcome to talk to me about it as well. I get very excited talking about Quarkus. Any questions before we move on to the live coding portion of the evening? I'll take that as a no, and let's jump in and have some fun. All right.
I see we have a hand up there. Gaurav Joshi, did you want to unmute yourself and ask a question?
Yes, please. My question is like, where in the industry we see Quarkus being used? So if you can give me some examples, like whether it's which kind of companies are mostly preferring this? Is it more of the financial or healthcare? If you can help.
Absolutely, I can. So there are public references on the Quarkus website. I can also say that this is my personal experience working with Red Hat. I have a number of accounts that range from retail to financial to healthcare and manufacturing. So those are sort of the industry blocks that I'm in. Out of that, all of them are considering or have moved some applications to Quarkus already. What it really depends on, what I've seen the tipping point move to it, is when they finally decide that doing something in a cloud native way is useful for their business. So a lot of businesses are still really just deploying applications, even into the cloud, the same way we've always been doing it. They may be, not running WebSphere on-prem, but they're still taking that same Spring Boot app and now running it in the cloud. And what they're realizing is that the economics of that really aren't in their favor now that there are some other options out there. Quarkus really is best designed, not exclusively, but best designed for new application development. And by new application development, I can also include in that refactoring of your existing applications. So if you were going to take a monolith and decompose it into microservices, Quarkus potentially would be a great fit for that. If you had some microservices that you wanted to deploy, and let's say they were doing a bunch of dynamic class loading, which is not going to work in Quarkus, by the way. Now, there are some ways to take a Spring Boot app and Quarkitize it, I guess. And sometimes it just works out of the box. It just depends on what's actually going on with the dynamic library loading. If you've got those microservices that perhaps you're running on-prem and you want to deploy those, but not refactor them at all, not take the time, there's no business justification for it, then don't do it. It's really all on the business justification for making the change. Now, if you're talking strictly greenfield, if you're talking a strictly greenfield application, then there is no reason to not evaluate Quarkus for those potentialities, particularly if you're deploying into Kubernetes or any flavor of Kubernetes like Red Hat OpenShift, or, and this is the one that's really awesome, as I mentioned a couple times, or trying to take a Java app and push it down to the edge and maybe have it run on a RHEL box.
Is
that helpful?
Can you talk a little bit about the fact of what are the most common restrictions of APIs? And I'm going to give you the one that I know is not really supposed to be used with Quarkus when we talk about Java APIs.
Okay.
Reflection
Yes.
is the top #1
Yep.
no.
Yep.
You talk about dynamic class loading. I'm talking about how many operations within Java use reflection that you don't know. As examples of this, I want to actually bring up some of the JPA and some of the Hibernate stuff that goes on inside of Java that you don't really recognize that is going on in the dynamic areas of maybe not loading, but actually auto-configuring your classes and so forth, and therefore they're not available.
That is absolutely correct.
My best recommendation for those who are not familiar with Quarkus is to only take the approved APIs that are off start.quarkus.io. You go to that start page and you select the needed, let's say, Hibernate or JPA libraries that you want and work with those directly, because then they will work, because they're a different set of APIs that are not common to the original libraries from Hibernate and JPA. And therefore, this is the best place to start, as is being said, as greenfield. Because of the pain that I have experienced in this space, please go to the start first.
Absolutely. And I think you hit the nail exactly on the head with that. It depends on the level of effort and whether it makes any sense to do at all. Greenfield is easy. Hibernate is there. If we get to it, we'll do some Hibernate later on. It's super easy to use Hibernate as an ORM with Quarkus. If you're trying to convert legacy applications, the easiest thing to do from an evaluation perspective is swap out the dependencies and see what happens. And then if it looks like it's too much work, don't do it. Find a different strategy. And that might be refactoring that app into a Quarkus app, but that would involve some significant rewriting perhaps, or it might be just keeping the application as it is. Not everything gets to be refactored. Not everything needs to be refactored. So you got to make those decisions. But yeah, that's an excellent point. Very good call out. All right, well, let's do some
Can I
code.
talk about one more thing?
Oh, absolutely. Yeah.
We're talking about serverless, okay? And I want to bring up the fact that there are totally different inferences of what is serverless meaning now inside of cloud providers. And I'm going to give you an example of containerization. You can run the same container inside of Kubernetes and run fine. It may start out slow. But who cares if you have like multiple replicates of it, and therefore you're only, let's say you're doing auto replication of your pods inside of your Kubernetes, therefore you set your CPU stress at like 60%, and therefore it'll spin up another member of the cluster to allow it to then be realized and therefore be running and be available when it gets to stress. But if you go from EC2 as an example in AWS, and you go to ECS. ECS is just another serverless that they're not really like defining it that much, but they're defining it on the event that it is needed. You can set a certain amount of it as a hotspot that you want so many of these things running in advance, but every time you spin somebody up, someone's going to feel the pain. And therefore, for the fact that you can pack more containers into less space inside of a Kubernetes space, it is to your advantage to use Quarkus. It is also to your advantage to use Quarkus because of the minimal latency that has been discussed on this call today, that you need to ensure the fact that you are the best of breed to your client. Otherwise, they will not be happy.
Completely agree. Very well said. Are you guys looking at my VS Code window right now?
Yes, I can see it.
Okay, I just wanted to make sure that I'm still sharing what I thought I was sharing. It's sometimes things change when you're not paying attention. All right, so as I mentioned, what we're going to do first is some live coding, and we're going to scaffold an initial application. So I'm not going to make you guys watch me type all of this. You'll get to watch me type later on. But what we're going to do is just do this Maven scaffolding that we had in the slides earlier. So we did that. We scaffolded our app. We now have a new directory called World Tour. So let's take a look and see what's in World Tour. And yep, that looks like the structure of a Java application. Awesome. All right, let's go ahead and open it up in VS Code. So now we've got our VS Code up and running. First thing we'll do, let's just take a look and make sure we know what's going on. We've got a main, we've got a Java, we have looks like some Java code, pretty straightforward stuff there. We have a pom.xml that's making me warm and fuzzy, very excited to see that. We've got some resources. We have an application.properties file. So this all looks like good stuff. So first thing we'll do is let's go ahead and run this application. It's a very simple web app. I'm not trying to show you guys the most exciting use cases, the most sophisticated use cases that you could do. And the reason for that is this is the first time that we're talking. So what I want to do, ZSH is very excited. Okay. Thank you, ZSH, for letting me know. What I want to do is give you guys a springboard into trying Quarkus on your own and to give you a feel for how easy it is as somebody who's already a Java developer to do something new, to do something modern and not feel like, well, those cloud guys that have taken off, I don't know how to do serverless, or man, I wish I could write some code and deploy it to the edge, but I don't know how to do that. So what I'm really going to try and do is show you how easy it is and how fun it can be to develop code with Quarkus. So the first thing we want to do is let's just go ahead and run our app in the dev mode. So that's just mvm Quarkus dev. Normal Java stuff. We're compiling. We've set up some listening for debugging if we were going to do that. And now our app is running. Notice it took a little over 2 seconds to do. And as I was alluding to earlier, Quarkus should be faster than that. That's because we're running in dev mode. So this dev mode gives us that ability to hot reload without having to stop our application, compile it, and then re-execute it and then retest. We can simply save and then test. I'm going to open up another window and use curl a bunch today just because we're doing web apps. We could also have a browser window open if we had, a more sophisticated application. But we won't be doing anything super sophisticated. But if we were, it'd be nice to have the browser window and we could just hit, Control R and see our changes. So let's take a look first. So curl localhost. So we haven't done anything but scaffold this app. And yay, so we're getting a response. That is great. Well, we talked about live coding. So let's see what I actually mean by that. So hello world tour. I saved that. I can come back and run my curl statement. Oops. And there I am. Hello world tour. I meant to put Quarkus in there. There we go. Save. Execute. This will be true basically with whatever changes you're made. So we're going to add new class files, not have to stop this app. We're going to add some methods here, not going to have to stop the app. We're going to introduce new extensions, which means adding dependencies into our pom.xml, not have to stop the app. So if you think about how many times you stop, start, compile, retest, that whole cycle, if you can just get into the habit of typing, coding, saving, seeing your results and moving on, it can really be a productivity boon. So let's move just a little bit further on, make it a little bit more exciting than just changing our return. And we'll do another get, just because they're nice and easy. And text plain, keeping it simple. Hit save. Making sure hello still works. It does. And goodbye from Quarkus. So as you can see, didn't have to stop the app. It's still running in the background. And we can just be productive and do things. So the next thing I want to do, I said that we could add dependencies. The dependencies that I want to show you guys today, and there's a number of them, and I've chosen these specifically to illustrate a couple of different points, mostly around how Quarkus is appropriate for modern Java development. So the first thing that we'll do actually is do an MV Maven, and then we're going to do Quarkus. So you're not supposed to have all these extensions memorized, which is handy. You can certainly go to the web page and read the documentation. That was a little bit quick. So let's slow that down just a bit. What I did was just list all the dependencies that Quarkus has ready to go right now. You can see it's quite the extensive list. So we've got a bunch of things on Camel. If you're doing, as I mentioned, enterprise integration patterns, great choice. Lots of ways to do Camel, lots of places to do Camel. The last JUG presentation last month was on GraphQL. If you wanted to do Camel and GraphQL, you can pull that dependency right into Quarkus immediately. Lots of other things around databases. Cogito is a Kubernetes native way of doing process automation, and using decision notation, things like that. Got OptiPlanner, lots of AWS stuff, lots of JDBC stuff, et cetera, et cetera, et cetera. So lots and lots of extensions. I'm going to pull in a couple initially, and I said I'm choosing these specifically. So the first one I want to do is the Open API extension. We're just going to add the extension. I can spell it correctly. I think it's just small right API. I got that right. One thing to point out, that extensions is plural there, and that's on purpose. We can, I didn't type it correctly. I didn't spell it correctly. Yep, extensions. But it is plural. I think that's right. Typing and talking is not a strong suit for me. Awesome, got it right that time. So we pulled in the open API. The reason that's so important, if you're going to do API-driven development, it's awesome to be able to then document those APIs and share them out directly with other teams, or perhaps give them some Swagger documentation. And we'll look at Swagger here in just a second for our APIs. So we have successfully added that extension. That's great. What does that give us initially? And do it with curl. And here is the not yet very exciting Open API spec for this particular REST endpoint, or set of REST endpoints. We've got both hello and hello bye. They are gets. They are defined as having response codes of 200, et cetera, et cetera. You could augment and annotate these with more information, change those APIs, put in different return codes, put in exception handlers, put in parameters, and all of that would be dynamically made available through the Open API extension or dependency. And in fact, since we've done this, let's go ahead and just take a look at our pom.xml. When we added that extension, finally, when I typed it correctly, this is actually what happened right here. We created a new dependency within the pom.xml. So no real magic to it. That's really what we did, is just pulled in a new dependency. So we have that. We also have the ability to look at the Swagger UI version of this. Swagger is one of my favorite tools. And the reason it is, typing and talking, not my strong suit. So here's our Swagger UI. And if you haven't used Swagger before, it is pretty awesome. It gives you this web page where you can very easily understand the APIs that you're given. This would include gets and posts and puts, deletes, patches, if you're a crazy person and are doing just wild things out there. You can fill in the parameters, and then what's awesome is that you can try it out. So let's say I actually had something with parameters. We could have put the parameters into the web page here, execute that command, and it will actually run it. It tells us what it ran with the curl command here, gives us the response body, all of the headers. The reason I love Swagger so much is that when I was an API developer, if I got a bug report from the QA team or from somewhere else in the organization, maybe a consuming application that my code was misbehaving with for some reason, I could point them at my Swagger API and I could say, here, go use this, create a curl command using Swagger and give me that curl command. Give me a way to reproduce this issue. It's a great way to share knowledge across an organization. The Open API spec is fantastic for that and really a great way to do API-driven development. So that's one thing, one extension that we can add, and you can see why doing cloud native stuff might be important for API native type things. Another one that is also really important in terms of cloud native deployments, Kubernetes deployments, OpenShift deployments, is having the ability to do health checks. So let's add the health check API. So Maven. Oh, look at that. Typed it right the first time. It's a miracle. So why are health checks, and what's included in that health check is both a liveness check and a readiness check. Why are those so important when you're deploying applications into a Kubernetes native environment? And really it comes down to a couple things. First off, Kubernetes is designed to scale your application horizontally. So what that means is when there's load, potentially, if you set it up that way, you may get another instance and another instance and another instance. It will start new instances of your application. Those instances might not be ready to receive traffic just because the application itself is started. Maybe they're making a connection to a backend database and it takes a little while to get that database connection established. Wouldn't it be great if there was a way to tell the hosting system, that Kubernetes system, yes, I'm up, but don't send me any traffic right now, I'm not ready. And then when it was ready, Kubernetes would repoll and say, hey, are you ready now? And your app could go, yep, fire it away. I've got the connection to the database. I'm happy to answer any question you've got. So that's really critical when you're running in a Kubernetes native environment. But also similarly, the liveness check. Now, if the whole pod crashes where the application's running, that's obvious to Kubernetes that says, hey, we need to start a new one of these. You said you wanted 3, you've only got 2. I need to start another one. That's really obvious. But what if the pod's still running and the application is no longer responding for whatever reason? It's essentially a zombie, mostly dead for all intents and purposes. Having a liveness check there, if that fails, then your Kubernetes system can go, well, the pod's alive, but the app's dead. I'm going to wipe the whole thing out and start another one so that you can continue to deliver on those service metrics. So it's really important to have both those liveness and readiness probes when you're running in the cloud. So let's go ahead and see how these work for us. We've deployed the extension. So we've got our readiness, and yes, we're up. This says, we asked the application, are you up? And it said, yep, I'm up. Notice there's a checks array there. We'll get to that in just a second. We can do the similar thing with live. And also, check says it is up. So that's great. We also have a health UI that we could look at. Back to my Firefox here. So we know that this application is up. It's not doing anything sophisticated down here. We'll get to that here in just a minute, but it is up. Typically, you wouldn't deploy the health UI into production. I mean, you could, but you would generally want to turn something like that off. But your liveness probes and your readiness probes, those should absolutely be deployed into production so that the system that is managing the application, Kubernetes, for example, or OpenShift, knows that the app is up, knows that the app is ready to receive traffic. So we've done that. Let's go ahead now. My window's in the way. Let's actually add some health checks. So what we're going to do is create a new folder called health, because I'm not super creative. And then we're going to create a new Java class. And this one is going to be, let's do our live probe first. All right, so we've got our simple health check.java. We are going to implement health check. So that's good. And this one will be a liveness. So what this gives us is the ability not just to have a generic response, but we're going to actually potentially write some code that gives us a custom way to say, yes, I am alive. All right, so we tried our aliveness check just a second ago. Let's see if we get anything different this time. And we do. Now that you see in that array, we actually have a section, and we've said, here is a simple health check, and the status is up. Now, really what you would do is you would have some logic in there that says, this condition, that condition, whatever those things might be, and then determine whether you're up or down. You wanted to see what the down looks like. Not really the best way to do a down health check by changing your source code, but just to illustrate the purpose, the point. There we go. Now you can see our simple health check is reporting down, as well as the overall status also says down. So this will be really important, as I mentioned, when you're running in a cloud native environment. Let's go ahead and do a little bit more potentially sophisticated from a readiness perspective. Create a new Java file. All right, so we've got our database health check. It will also implement health check. This time it will be readiness. We run our readiness check. So similar thing, we could have a variety of checks, and this one also reports up. Window is covering up my notes. All right, so rather than, I think you guys watch me type, I'm just going to paste in here what I had going on, and this just makes it a little bit more fun. So what I've done is I've said, okay, let's just create a new random integer and then figure out if it's even or odd. And if it is even, let's say we're up. And if it's odd, let's say that the database is down. And really just illustrating that you can, one, have different types of checks, readiness versus liveness. And then depending upon the result of individual checks, and you could have more than one, that could reflect the entire status of the application. So we were down and now we're up. So pretty cool stuff, pretty exciting and fun to do. One thing that you have not yet seen me do is recompile my code. We are still running in dev mode. We are still running in this same, when I did Maven, Quarkus dev, we haven't changed anything. We brought in extensions, we added class files. We had a couple typing errors, And we just kept on coding, kept on being productive. The one thing that's interesting here, and this is one of the new features that I think came out in Quarkus 2. Notice at the very bottom here where it says tests pause, press R to resume testing, or toggle the test output, and I've got more options. So what Quarkus did in dev mode is it didn't assume, oh, you want to run the tests all the time, but because the idea is to make the developer productive. And if you keep running the test, they might not be quite so productive. But maybe we do want to run the test. Maybe we should, periodically see if the code we've implemented is still passing the tests. So I'm just going to hit R down here and see what happens. So now I'm starting tests. One test is running. I only had one because it was scaffolded for me. And oh no, look at that. The test failed. Why did the test fail? Well, when we look in here, it was expecting hello rest easy. Remember when we scaffolded the application, that's actually that very first string that was returned out of the scaffolding. And then we made some changes to it. And we actually are returning now, hello Quarkus World Tour. So depending upon what the right answer is, maybe we change the code to go back to hello rest easy, or maybe we change the test to match what we're actually doing in the code. I'll go ahead and change the test because I like hello. Where'd my test go? I like the Quarkus World Tour. So here's my testing resource. I'll open this guy up and we will just fix it up and then rerun our tests. Notice I just hit save and it ran the test for me. I'm not sure if that was terrifically apparent. Let me put an exclamation point in there because I tend to be pretty enthusiastic about this stuff. So here is my exclamation point if I'm typing. Come on, mouse focus. All right, so I added an exclamation point. I'm going to hit save and my test should go back to failing. Boom, and it's failing. So we didn't have to stop and start or any of that type of stuff. We're just writing code. We're being as productive as possible and getting stuff done, aside from my mouse, which is not cooperating. All right, so all of our tests are passing now. Good stuff there. So what's next? What's next? All right, so we've talked a lot about Quarkus being a platform for cloud native deployment, cloud native applications. One of the things that can be easy to say, hey, it's great, go deploy your apps onto Kubernetes. You're going to have Java developers that are like, what the heck's a Kubernetes? I'm a Java developer. I don't know how to deploy apps on Kubernetes. I don't want to know how to deploy apps on Kubernetes. I want to write Java. Why is this getting in my way? We're going to add another extension now, and we're going to actually deploy this very simple app onto a Kubernetes platform that is running up in Amazon somewhere. So we'll do that here now, and we're going to do it exactly the same way. We're going to add an extension, and then we will, actually, we're going to need to make a slight modification to our properties file so that we'll trust my self-signed certificate in my cluster. And then we'll go ahead and build and package this application. We'll build it in a jar file, and we will ship it out there, and then we'll test it and see how that goes. The idea behind this extension, of course, is to make the developers' lives easier. Yes, it would be awesome if everybody knew about Kubernetes and wanted to be, an expert in Kubernetes. Not everybody does. So, for the folks that don't need to know that, they shouldn't have to have that be a barrier, have it be a speed bump, have it create friction for them in their job. Let them code. All right, so I am going to deploy to an OpenShift version of a Kubernetes cluster. So we'll use that particular extension. And I do need to, I'm going to paste this so I don't misspell it. It doesn't work if I misspell my properties file. What this is actually doing is saying to go ahead and trust that certificate. Not something you want to be doing if you're deploying your application into production, but for me, who doesn't have a cert for my Kubernetes cluster, this is a nice workaround. And also, lots of folks are working with internally signed certs in their own organizations. And so this is a way to make sure that, again, you don't have those barriers and roadblocks. All right, so we have done that. And now what we're going to do is, there's two ways to do this. You could actually create the jar file and in a container and then push that, or you can push the jar file and have the container created on the remote system. So we're going to do the second. We're going to do the whole shoot and match, deploy this thing. And I am going to stop my live coding currently, just so that it doesn't get in the way. All right. So what this says is that we've got the Maven stuff. We're going to clean it. We're going to create a package. We're going to skip tests, although they're passing now, so that's fine. And then we're passing in this new flag, deploy this to Kubernetes. Go ahead and deploy it out to Kubernetes. So I'm going to hit enter. It's going to take a little bit because it's going to have to clean and package, and then it's got to push this jar file across the world and then start up this application. So while it is doing this, do you guys have any other questions? We're just going to watch this log output for a minute or so, depending upon how fast my Wi-Fi is right now. Because this is literally coming from my laptop into Amazon land, wherever that might be. I can tell you it's not.
My one suggestion would be to offer an alternative to the way that you're showing this right now, and another way to simplify the developer experience is to use something called JCube for Java people. Yep. Because the fact that JCube is allowed to be added to the Maven dependencies, and therefore you can have multiple goals inside of Maven to allow it to be cleaned, to be compiled, to be basically look at your manifest file, and also to then deploy to whatever you have your kubectl set to allow it to be deployed. And therefore, if you have your CLIs, as you said, set up correctly, therefore you could deliver it to AWS, like you installed your AWS CLI and then your EKS CLI, therefore you could deliver it that way inside of Maven.
Absolutely. No, that JCube is an outstanding tool. I have no argument with that whatsoever. It's a really good call. The other thing that could be interesting is from a Red Hat perspective. Red Hat does have a lot of developer tooling, or specifically targeted at OpenShift. So if there's where you don't even have to know Kubernetes at all, it's very much OpenShift native. But yeah, I love the suggestion and the call out of using JCube. That is
even with OpenShift.
Yeah, no,
JCube
absolutely.
does support it. JCube supports OpenShift.
Yeah, no,
not just Kubernetes.
It's an outstanding tool. All right, so this is my OpenShift console. We'll log in and see if we actually have our application deployed. And it looks like we do. We've got our Quarkus World Tour, and we can open up our URL. So this is a little bit like Spring Boot. When you have your application deployed and you've got essentially a splash page for your app. When you get ready and compile this, or get ready to move beyond just the initial uses of the tool, take this out. And what was our path? Hello? There we go. Hello, Quarkus World Tour. So that was it. The idea being, like with JCube or how I just showed you here, very easy to take what I've been saying is a Kubernetes native Java and actually get it into Kubernetes in an easy way, and in a way that actually could be automated and, like you said, certainly appropriately, even included into Maven and within Maven tasks and goals. So that is an outstanding call out, and I love it. All right, let's take a little bit more time and let's look at what it looks like to run this application locally. So what I want to do, I spoke earlier about start times and I spoke earlier about memory consumption. So let's actually dig into that a little bit, dig into the start times, dig into the memory consumption, and not including starting in dev mode, which is not exactly the same thing. So we'll do a java-jar. We've got our target directory, got our Quarkus app, and our Quarkus run.jar. All right. So this should give us the same application that we just looked at. It started in 1.7 seconds. So that was something. Let's give it a shot again, see what we get going on. Just get some consistent numbers. 1.5 seconds. Yes, that's about right. This is running in JVM mode. We're doing a java-jar, a little bit more than a second. Okay, yeah, so somewhere between a little bit more than 1 and 1.5 seconds to start this very simple application. The other thing that we should do before we go away. So what did we say? We said between 1 and 1.5. Let's take a look at how much memory this is actually using while it's running. So this will be dependent if you're using a Linux system or something else. These commands might be slightly different, but essentially what I'm going to do here is run the PS command, and then only for the PID of my Quarkus run, which is the application that we just set up and running, and then look for the PID and then the RSS, which is the resident set size. That's actually the RAM being used when the application is running, and then the command that's actually running. So we'll go ahead and run this. So this is my resident set size of 300,000 kilobytes. This is actually in kilobytes. So this is 314 meg, I think, if I'm moving my decimal correctly to the left. So a couple hundred megabytes just to do this very simple JVM application. So we had a 1.5-minute start time, and then we've got our native JVM application. So what I want to do now is compile this into, I'm going to stop the other one running first. Compile this. Oh, let's actually make sure it was the right app. I like to make sure I'm actually running the app I think I'm running. Runner, hello, yep, hello world tour. Okay, good stuff. So we are running the app we thought. And we had 300 and something megabytes of RAM being used in memory. We shut that down. We're no longer running the application. And what I'm going to do now is package this as a native app. So all right, let's fire this guy off. Now this one will also take a couple minutes to run. It's pretty informative to look at the output of this and to see what's actually going on to make it a native application. We'll get past the tests, or the whole one test that we're running. And then it'll start doing it. All right, here we go. So while we watch our output here, and as it is building not a Java app, but a native Mac executable, any other questions, thoughts, or comments as we're on this section? The comparison between how an application runs in a JVM versus how an application might run compiled to a native executable, or anything else really. Has anybody here delivered Java code into the cloud? You guys writing any cloud-based Java apps?
I have.
Yep.
I've been doing it for a health company for 3 months.
Okay.
We had to change their thoughts about using Spring Boot because the fact that they wanted to honestly go to an idea of a faster startup and a higher density of containers. And I offered this, and I was teaching offshore for 3 months doing this way. when they figured out like the Hibernate and the JPA issues that I was teaching them, because they wanted to use it very directly with the code that they already compiled already. And just to let you know, it would not work.
Right.
It's really because of the reflection APIs and the annotations that were in the Hibernate and the JPA side of things. And therefore you have to change the classes that you use to allow this to work. And therefore it worked very fast and they were very happy with it. Then they wanted to go to quote unquote, when we say serverless, now we have to talk about what Lambda is. And therefore there is no context inside of a function. Therefore you have to understand how you're using Quarkus that way. And therefore that's why I left the company, because the fact that they didn't like the thoughts because it was too hard to understand it. And they were taking too much time to create only one function. Oh my gosh, just one function. And therefore that's the problems that you have to think about before you offer some of these solutions, to make sure that everybody is on board and that they can easily understand the APIs that you're using to make these things possible.
One of the comments, and I think you're spot on with that. One of the things that I would say, and I will put on unapologetically my salesperson hat here, is Lambda is not the only way to do serverless in the cloud, right? That is an AWS specific thing. The way Red Hat does it is using the Kubernetes Knative. And Knative is actually a much easier way, I think, of creating a serverless application. You can actually, I mean, like Lambda, you can create a serverless application basically out of anything. It doesn't mean they're all appropriate to be serverless. But yeah, thank you for that comment. I think that's really spot on, that you need to know the reasons why you're doing things and not just be doing them. All right, so we have now a native executable. So let's take a look. So in my target directory, I now have this new thing. It's in red for you guys actually, called blah, 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 runner. That is my native executable. If I run the file command on that, notice that it tells me this is a Mach-O, so that's for my Mac, 64-bit executable on this particular architecture. This is a native Mac executable. If I were to try to run java-jar on this, it would tell me no, because it's not a Java app. If I were to run file on one of those jar files, just as an aside, if you wanted to know what a jar file was, it's actually just a zip file, which is what a file would tell me. So let's go ahead and start this. We're going to run this native Mac executable. Now, I'm trying to remember, we had start times between 1 and 1.5 seconds using the JVM in our very small app. And we had memory utilization of 300 and something meg, 314 meg or something like that. Let's go ahead and fire this guy off. So target, and then world tour, snapshot, runner. Now again, no java-jar. This is the executable itself. All right. And the Mac tells me, hey, do you want to allow this? Yes. Thank you for being concerned about my security, Apple. All right. So how long did this thing take to start? 0.029 seconds. 0.029. That's pretty darn quick. From a serverless perspective, that's pretty much instantaneously. The time to first response would be very adequate running in a serverless context. 0.29 of a second to start versus 1 to 1.5 seconds. 0.29, pretty darn awesome. And since we did this the other time, let's just make sure that wasn't an aberration. 0.58 of a second, 0.33, yes. So roughly the same magnitude of start times. Really, really, really fast. However, we also said early on that start time was important, but also memory utilization was important. So we have the app running right now. Again, let's make sure it's actually the right application. Oops, there we go. Which one of these guys do I want? There we go. All right, so curl. All right, so yes, right at. What is our memory requirements on this guy? So basically the same command, except that now I'm going to look for a process that has a runner in it versus, what did I have the last time? Quarkus, whatever it was. All right, here's our resident set size. So our previous resident set size was 314,000 kilobytes. This is 22,000. So we went from 300 meg to 22 meg. 300 meg using the JVM to 22 meg as a native executable, delivering exactly the same functionality. Now, I know the functionality is not all that exciting. And as we built more into this, both of those numbers would grow. But the percentage difference would likely remain basically the same. And so you can see how if you are scaling things horizontally, you can do so much cheaper scaling something that costs you 22 meg of memory versus 314 meg of memory. So that was good, but that is a Mac executable. And really, in the real world, Mac executables, not all that useful. So what I'm going to do now is actually build a native Linux executable. How do you build a native Linux executable on a Mac without using virtualization, VirtualBox or something like that? And really what's happening is a Docker image is going to get checked out. You see it right there, actually. This is a universal base image, which is a rel image. And the build will actually happen inside that universal base image so that I'm actually executing all of those build commands of my source code inside that Docker image, which is essentially rel on the inside. It's the universal base image for Quarkus. And so we can let this guy run a little bit. I think I did the one I wanted. So what we can do here, once this is built, you're like, okay, great. You built the native Linux executable, but you're running on a Mac. What the heck are you going to do with that then? Well, you could share it, right? It could be part of your CI/CD process or things like that. We talked when we saw our pipelines about how things happen. This is a great example of all of this work happening at build time versus runtime, because you're only going to build this thing once, really. And if you think about deploying it, you build the artifact, it goes into your artifact repository, JFrog or Quay or Harbor or whatever you might be using for that type of stuff. And then that build, the result of that build is repeatedly used. So from a developer perspective, do you actually build native executables? Not really. There's no real need for it. You might want to test it. You might want to look at memory set size and things like that so that you can report back to your operations teams. Hey, I think this app is going to need X amount of memory when we run it in prod, and we think we're going to need to run X number of instances, and they'll be able to better allocate resources for your application and understand its characteristics as it runs, etc. Typically, you don't do this as a developer. This is not, I've been hawking the developer speed benefits of using Quarkus. This is not part of the speed benefits of using Quarkus from a developer's perspective. This step would happen in your CI/CD process. You'd be writing your code, running your tests, doing all of the live coding that we did earlier. Finally, you would commit it. And then if appropriate in your CI/CD process, you'd create a native Linux executable. Now, if your native Linux executable, if your CI/CD process was running on a rel server, then you wouldn't have to use the Docker image to do this, but this is a nice way to do it that actually makes it possible to do this on my Mac. All of that being said, as part of our scaffolding, I don't know that if you noticed this, but we have a Docker directory over here that came as part of the scaffolding. And we in fact have a Docker native Docker file that is .native, which you can't see much of because I expanded my terminal window so high. All right, so let's see what we've got. So we actually have some pretty nice instructions. You can see that I used this one earlier. We could have done this one as well. It would have been the same output. And if at the end of this, I think I should be able to run this command here. And if I can't, then I'll have to run this one and then this one, but we'll see how it goes. I might as well copy it, so I'm going to try and run it once this is done. The other good thing about creating native executables on your laptop, if you haven't heard your fan on your laptop run in a while, and you wanted to check and see if that fan was still working, creating a native executable is pretty much guaranteed to kick your fan off. It gets pretty smoking hot doing this. Are we running out of time here, Bruce?
Actually, you're okay.
What time do we need to
wanna-
wrap up for our drawing and stuff?
I would say about 8:30.
All right. All right. So we got a couple more minutes here. I can tell you I'm running out of voice. All right. So we've now created a new executable. Let's see what we have in our target directory. So we still have our runner, and let's do file on that rascal. Yes, success. So notice when we did that last one, it was a Mac executable. This is now a 64-bit Linux executable with a whole bunch of information here that we didn't get on the Mac side. So a completely different thing. And if I tried to run this, which I can do, and what did we say, world tour runner, this is not going to work. You cannot run Linux executables on your Mac. Nope, not going to happen. Similarly, I couldn't have shipped that Mac executable off to run on a Railbox. Also not going to happen. So we've got this guy. Well, how do we run this then? We wanted, so here's the premise I'm operating under. The thought was, oh, you know, I'm done with I've got my application run and I think it's going to run really well as a Linux executable. I want to compile it up. But before I share that out with the world, wouldn't it be nice if I could run that myself locally and not run into some embarrassment in case there's some, you know, strange bug that I was unable to account for? Oh, my address is already in use. That's not good. Yeah, I still left it running. All right, let's kill the other one. And we'll try this again. There we go. So even running in a Docker container, you can see that my start time as a native executable is still faster than a JVM. Still is just over a half a second. So saving about a half a second. Now this is again, not how this would look running in a production environment or a Kubernetes environment, but it does give you the ability to run that Linux executable locally without too much effort. Be able to evaluate that. Is there anything else? I don't think there's too much else that I want to accomplish with you guys today. I don't have enough time to do the live testing, I don't think. That's okay. Maybe we can table that for another day or do some more sophisticated things. As a recap, I hope that really the main takeaway was you're a Java developer. You don't need to be locked out of doing modern Java development, whether that's deploying to the cloud or deploying to the edge. You've got all the tools, you've got the knowledge that your business needs to be able to create these apps and you know, continue to create value. Do not let those Node.js guys eat your lunch. you can be a serverless developer too. You can make it happen, or an edge developer, which I think is just, opening up a tremendous avenue for Java developers, particularly as we've been locked out of the edge. But really, Quarkus is a Kubernetes native Java designed all around making Java developers more productive, as well as improving the economics of running Java code in the cloud. And I think that's all I've got for you, Bruce.
Okay, well, thank you very much. Does anybody else have any questions for Chris before I turn things over here for the raffle?
I would just like to express my appreciation for him to be here on this meeting, because it was very important for, I think, a lot of people, and even me, foreseeing other possibilities.
I am going to send the slides along to Bruce so he can distribute that to the group. And you guys are more than welcome to reach out to me directly if you want to talk about Quarkus and whatnot. Or, I'm delighted to come back and do some other stuff with you guys.
Okay, do you have a slide maybe you could show with your contact info if you're comfortable with that, so people can contact you just for the recording?
Yeah, absolutely. I will. Let's see. Where'd my slide deck go? I gotta find my slide deck. Well, I'll tell you what, the easiest thing, because I'm so sneaky, is it is not that one. It is cbolland@redhat.com.
Okay, well, there you got it. Bolland
At redhat.com. I have lost my slides.
Okay, yeah.
But yeah, cbolland@redhat.com. And before I give those to you, Bruce, I'll put it in there.
Okay, all right. Well, thank you very much.
Absolutely.
So if nobody else has any questions, then I'm going to stop the recording, and then Ted will take over for the raffle.